The video has started. Alright, number 1. Classify each polynomial by degree and number of terms. So this first problem, negative 2x squared minus 9, is a quadratic binomial. Number 2, the highest degree is 5. That means it is quintic. And it's 4 terms, so that's polynomial. Number 3, it's cubic because of the 3rd degree, and it is a monomial. Okay, for the next section, you have to simplify each expression by either multiplication, addition, subtraction, or just basic division. Final answer should be written in standard form. So in this first problem, we've got an exponent outside the parentheses here, which means that we need to distribute that exponent onto each of the exponents inside the parentheses, which means negative 4 to the 4th, which will give us a positive 216, I believe. .256. So 256 m to the 8th n to the 4th times 1/6 m to the negative 10 n to the negative 4. Alright, so now we need to multiply the 256 and the 1/6. 256 over 6 reduces to 126, 127, 28, 128 over 3. M to the 8th times m to the negative 10th would be 8 plus negative 10, which is negative 2, so you're going to have m squared in the denominator. And then your n to the 4th times n to the negative 4th cancels out, so this is your final answer. 128 over 3m squared. Alright, number 5, you're adding, so combine your like terms. 8a squared minus 7a squared is just a squared. Done with those. Negative 8a minus 6a, negative 14a. We're done with those. And then negative 6 plus 1 is negative 5, and we're done with that. Yep. Number 6, we're going to subtract. That means we have to change signs. So, our largest exponent is cubed, so 2x cubed. And then negative 7x squared minus 5x squared is negative 12x squared. And then 6x minus 2x is 4x. And 7 plus 1 is 8. And we're done. Make sure you put it in standard form. No. Could you divide them all by 2? Yeah, you could, but there's really nothing to set it equal to, so there's no reason to factor it out. You could factor a 2 out if you wanted to.
Madison Edwards Company.
Okay, number 7. Now, this is going to be pretty long and tedious. So what you have to do, hold on just a minute, is say y plus 4 times y plus 4 times y plus 4 minus 2y times y minus 1. Now, there is actually a shorter way to do this. We talked briefly about it the other day. It's called, you use the binomial theorem for this. But we really haven't got into the practice of that yet, so we're not going to use that. Now, what you have to do is multiply 2 at a time. So when we multiply these first 2, that gives us y squared plus 4y plus 4y plus 16. That becomes y squared plus 8y plus 16. I just canceled out those 4 y's, added them together, and gave us 8y. That gets multiplied to y plus 4. And then you can go ahead and simplify this. It would be negative 2y squared plus 2y. Now, we have to distribute. So that we're going to have
sidebar, come to the front.
Y cubed plus 4y squared, and then plus 8y squared plus 32y plus 16y plus 64 minus 2y squared plus 2y. It's long, it's ugly, but it's not hard, it's just tedious. Alright, so y cubed is the first term. 4y squared plus 8y squared minus 2y squared comes out to be, 10y squared. And then 32y plus 16y plus 2y is going to be 50y. And then plus 64. So it's not hard, it's just tedious, a little bit time consuming, a little bit space consuming. Alright, number 8. You can do the same thing here. You distribute. So 3k times k squared is 3k cubed minus 3k squared plus 21k. Then you distribute the 6, or the negative 6. Negative 6k squared plus 6k minus 42. So 3k cubed minus 9k squared plus 27k minus 42. Whoops. There you have it. Alright, number 9. Again, it's tedious because we're going to just have to divide each of the terms by the denominator. So it would be negative 8c to the 6th d to the 4th divided by 8c squared d plus 56c to the 4th d squared over 8c squared d minus 24c squared d over 8c squared d. Alright, so we simplify. Negative 8 divided by 8 is just negative 1. C to the 6th divided by c squared is c to the 4th. D to the 4th divided by d is d cubed. Next, 56 divided by 8 is 7. C to the 4th divided by c squared is c squared. D squared divided by d is d. Next, negative 24 divided by 8 is negative 3. And then the c squared, c squareds, d cancel out. So this is your final answer. Alright, number 10. Determine the end behavior, whether the function is even or odd, and the sign of the leading coefficient given each graph below. Alright, so end behavior. This is when we did as x goes to infinity, f of x in this problem goes to negative infinity. As x goes to negative infinity, f of x goes to positive infinity. Now, if I ask you to do that, I will write this out and you'll just be filling in the blanks. Alright, it is odd because it goes up to the left, down to the right, and negative. If it goes opposite directions, it's odd. Number 11, as x goes to infinity, f of x goes to positive infinity, and then as x goes to negative infinity, f of x goes to positive infinity. And this is even, positive. Alright, flip it over. Okay, on the back, in order to do this, you need to graph this on the calculator first. And so when we do that, okay, x cubed plus 8x squared plus 16x plus 7 graph. So you can see what our graph is supposed to look like. So when I plot that, it looks like there's a point, 1, 2, 3, a little just to the left of 3. It appears there's another point just to the left of 6. And it also appears that there's a point just to the right of negative 1. I said 3 and 6. Negative 3 and negative 6. And there's a point just to the right of negative 1. And if we trace this, we see that it crosses the the y-axis at 7. 1, 2, 3, 4, 5, 6, 7. And so our curve is doing this. Okay? Not a great drawing, but it's okay. Alright, now the domain of this function is going to be from negative infinity to infinity, because that's what the domain is for all of these functions. The range for this one happens to be negative infinity to infinity as well, because it goes down forever and up forever. The relative maximum will have to be found by using your trace function. So when I go down, when I go to the peak, the hilltop, if you will, on the graph, you see that the x value is negative 4.0, and then the y value is going to end up being 7.0 to the nearest tenth. So, negative 4.0, comma 7.0 for the relative maximum. And then the relative minimum is down here at the valley. And down in the valley, it is negative 1.3, negative 1.3, comma negative 2.5. There's only one maximum and one minimum. Alright, end behavior. I'm looking at my ends. As x goes to infinity, y goes to infinity. As x goes to negative infinity, y goes to negative infinity. I told y'all we weren't going to worry about the intervals of increase and decrease. Alright?
Is that infinity to negative infinity?
Yes. Okay, number 13. Go back to y equals, delete the previous function, start over. X to the 4th, actually negative x to the 4th, negative x to the 4th, plus 3x squared plus 2x, graph it. Okay, so you can see what the graph looks like there. I'm going to zoom in a little bit because it's kind of hard to see, so I press the zoom button. I'm going to go to zoom in, press enter twice, and you can see it better. Alright, so having done that, it appears that it bounces off the graph at negative 1, so I am going to put a point at negative 1, and then it crosses at 0. It's going to be a tight graph here. And then it crosses at 2. So if I do this, it's going to be, and knowing that this is an even function and it faces down, when I draw my graph, it's down on the left, down on the right, so it's going to be like this, bounce, back up, and then immediately back down. So this is not a great, drawing. Get rid of that right there. Alright, so that's kind of what it looks like. Now the domain is the same as it always is. Negative infinity to infinity. The range here is a little different. And because I need to zoom back out again so I can see a little better where my maximum is. Alright, so I can see what my range is going to go from negative infinity, because it goes down forever, all the way up to whatever that highest y value is. And I can use my trace button for that. It appears to be about 4.7. So I use a bracket for that. That's also my maximum. That's one of my maximums. So the maximum, one of the maximums is whatever these coordinates are, and they are positive 1.5, comma 4.7, and then the other one is over here where it hits the graph, and we saw that was, I'm just going to say negative 1, 0, because we know it bounces right there. And then the minimum is down here, and it's approximately negative 0.2, comma negative 0.3. Alright, what was your question, Cal?
Why don't you use a bracket on the full?
Because it touches it. It actually includes that number. So if it includes the number, you have to use a bracket. Okay, the end behavior of this graph. It's going down on both sides, so negative infinity both places. If it goes up, it's positive. If it goes down, it's negative. That's that simple. All right, last little part here has to do with multiplicity and zeros. So, we see that the zeros of this function are 0, 1, and 8. The multiplicity of the first 0 here is 3, and then 2 for the 1, and then 1 for the 8. So, multiplicity of 3 tells us there's a twist. 2 is a bounce, 3 is straight through it. Alright, number 15. Again, I've got a 0, a negative 3/5, and a 2. The multiplicity of 0 is 1. It is 3 for negative 3/5, and it is 8 for 2. So, multiplicity of 1, straight. Multiplicity of 3, twist. And multiplicity of 8 is a bounce, because there's only one way to describe an even exponent, even degree, and that's with bounce. Last one. The graph of a polynomial function has zeros of 0, multiplicity 2, 1 multiplicity 2, and 5 over 2 multiplicity 2. Write a function in standard form. We're going to change that to factored form that could represent this function. So, f of x equals parentheses, or x, and then parentheses, x what? X minus 1, and that is squared, and the x is also squared, and then, good, 2x minus 5, and that is squared as well. So that's it. It's in factored form. If you wanted standard form, you have to multiply it all together, which I'm not wanting you to do right now. Alright, so that is the study guide. Tomorrow's test will be very similar to this, so hopefully you'll do well. Yeah.